Hello students, welcome to the class of EDCA. So let us see in this video the fifth module that is dealing with the alternators. Okay, so before that we have studied about DC generators, right? So DC generators are used to produce DC voltages, right? So DC generators, we are used to produce the DC voltages, and now we can study about the AC generators. So this module we can deal with the AC generators which are used to produce AC voltages. So this is the AC voltage with respect to time, and let this be the magnitude of the voltage. Okay, so alternators are nothing but AC generators. So in this module we can study the details about the AC generators which are used to produce AC voltages. Okay, so AC generators, there are two types of AC generators, that is synchronous generators and asynchronous generators. Okay, so synchronous generators are nothing but generators which run in synchronous speed, that is given by Ns is equal to 120 F by P, where F is the frequency and capital P is the number of poles. Okay, so synchronous generators are those generators which always run in synchronous speed given by Ns, and asynchronous generators are generators which run in more than synchronous speed, that is the rotor of this generator, at the speed of the rotor of this generator, consider Nr, will be greater than the synchronous speed. Here the rotor speed will be is equal to the synchronous speed given by 120 F by P, where F is the frequency and P is the number of poles. Okay, so this is the synchronous. There are two types of AC generators, that is synchronous generators and asynchronous generators. So let us see what you mean by alternators. Okay, now let us see what you mean by alternators. So alternators are nothing but they are machines which convert mechanical energy into electrical energy, at a particular voltage, and fixed frequency. Okay, so this is the specialty. So alternators are AC generators, they are nothing but AC generator, that is they convert mechanical energy into electrical energy at a particular voltage and at a fixed frequency. Okay, so in order to generate in a fixed frequency, in order to keep this from this equation, in order to keep this frequency a fixed value, then we have to keep the speed of the machine in a fixed value, that is the alternator will be running in a synchronous speed. Okay, since we know F equal to Pn by 120, to make the frequency constant, and P is a constant and 120 is a constant value, we have to keep the speed also a constant. So alternators will be always running at a constant speed run given by Ns. Okay, that is the synchronous speed, therefore the name came synchronous generators. Okay, now let us see the construction of the alternator. Now let us see the constructions of the alternator. So alternator is a rotating machine. So as any other rotating machine, it consists of a stator and a rotor. So the alternator also will be consisting of stator and rotor. So in DC machines, we have seen, in DC generator we have seen, that is we have kept the field winding, okay, field winding in the stationary part, and we have kept the armature winding in the rotating part, right? So in DC generators we have seen we have kept our field winding in the stationary part, that is in the stator we have kept the field winding, and in the rotor we have kept the armature winding. So this can also be included, this type of construction can be also implemented in alternators, but due to many advantages we are keeping the armature winding, in the stationary part, that is in the stator, and we are keeping our field winding in the rotating part, that is in the rotor. Okay, so this is the construction detail. So as any other rotating electrical machine, alternators will be having a stationary part, a stator and a rotor. So in this construction, due to many advantages, we are keeping the armature winding, our armature winding in the stationary part and our field winding in the rotating part. So as a construction, let us see, it consists of a stator and one rotor will be here, okay, and one rotor will be inside this. So this is the stationary part. So if it is a 3-phase alternator, we can take R, Y, B. Okay, so in the stator we have said we are keeping the armature winding, that is the 3-phase armature winding will be included in the stationary part. Okay, and in the rotor we are keeping the field magnets, field pole is keeping in the rotating part. Okay, so these are the construction of an alternator. So let us go in details with the stator and rotor of the alternator. Okay, so in the construction details of alternator, so it consists of stator and rotor. So according to the rotor construction, the alternators are again classified into salient pole alternator and non-salient pole alternator. Okay, so according to the rotor construction, the alternators are again classified into salient pole alternator and non-salient pole alternator according to their rotor construction. Okay, so coming into stator, the stator is made with cold rolled non-oriented steel with 3% silicon and is laminated to reduce the eddy current loss. Okay, so this is the construction detail about the stator. So the stator again consists of a stator frame and a stator core. In the stator frame is nothing but the outer coverage of the machine. So it is used for holding the armature stampings and the windings in position. Okay, and the stator core is used to support the armature conductors. Okay, so and is built of laminations and it's made up of magnetic iron or steel alloy. The core is laminated to minimize the loss due to eddy current. Okay, so this is the different shapes of the stator core. Okay, now coming into rotor. The rotor, as I have said, there are two types of alternator. We can say according to the rotor construction, we can classify the alternator into two types, that is salient pole and non-salient pole, or its name is cylindrical pole type. Okay, so coming into salient pole and non-salient pole, so this is the pictorial difference between a salient pole and non-salient pole. So this is the stator part, the outer coverage is the stator part. So the inner, the type according to the rotor construction, so there are two types of rotors. This is the salient pole, that means projected poles. The poles are projected, so therefore the name came salient pole. And this look like a cylindrical pole. Okay, therefore we can say it is non-salient pole or cylindrical pole. Okay, so in this here the field winding will be wounded through this field poles. Okay, the field winding will be wounded through this field poles. The field winding will be excited with a DC voltage, and whenever the field winding is excited. These are electromagnets. When the DC voltage is applied, the field magnets will be excited and the poles will be created, and hence the magnetic field will be rotating and the stationary armature conductors will be stationary. So there is a relative change between the flux and the conductor. Therefore, a conductor, an EMF will be induced in the stationary conductor, and from that conductor we can take the electrical energy. So that is the working principle. So according to the rotor construction, alternators are classified into salient pole and non-salient pole. Salient pole means the projected poles, and non-salient pole or the cylindrical poles are named according to their rotor construction. Now let us compare about the salient pole and non-salient pole alternators. Okay, so salient pole alternators, so it is used in a low and medium speed alternators. They are not used in high speed alternator, they are used in low and medium speed alternator. So it has a large number of projected poles having their core bolted on the heavy magnetic wheel of cast iron. Okay, such generators are classified by their large diameter. So they are having large diameter but short axial length. The poles and pole shoes are laminated to minimize the eddy current loss. The field winding consists of rectangular copper strip wounded on the edge, and the number of poles will be more since the speed is less. Okay, since the speed is less, we can see the poles will be more. That is to keep the in a constant speed. If the speed is less, we have to keep the number of poles more. Okay. Now let us see about the smooth cylindrical type or non-salient pole alternator. So this type of construction is used in very high speed alternators, which is nothing also called as turbo alternators. Okay, the rotor consists of smooth cylindrical having number of slots milled out at intervals along the outer periphery for accommodating the field coils. That is, the core is milled out in order to keep the field. So here only the field windings will be accommodated in the cylindrical pole. Okay, so such rotors are designed for mostly two poles. Okay, so that is due to since the speed is very high, we can keep the number of poles minimum. Okay, so such rotors will be designed mostly for only 2 or maximum 4 pole. So they are also called as turbo generators, which will be running in very high speed, that is about 3600 rpm. The poles are non-salient type. Okay, they have very small diameter. The diameter will be low, but they will be having long axial length. Okay, so the cylindrical construction of the rotor gives better balance and quieter operation, and also less windage loss. So this is the advantage about the cylindrical construction. The rotor balance will be more and will be a quieter operation, and the losses will be less compared with the salient pole alternator. Okay, so this is the comparison between the salient pole and non-salient pole alternators. So the alternators are classified based upon the rotor construction. The alternators are classified into salient pole and non-salient pole alternators. Okay, thank you.